Welcome to the first section of the course Algebra Mastery, which is going from the grade 0 to 5 in algebra and hopefully helping you get the grade that you want. I'm going to talk today about, or this first session, about these first 6 questions. So we can break it down. It's been voted that we're going to do it into smaller videos in playlists. So here's going to be the lecture number 2, which is after the introduction. And just a reminder, these lectures are 100% human-made. I'd like us to talk about one major way that I've seen tripping people up over the years is a structure. Okay, so keeping structure, I'm going to put that on some sort of t-shirt and sell it, because structure is how you don't lose sight of what happens next in maths. Okay, so this is a structure, question number 1. The fraction bar there means division, and it's the top divided by the bottom. If we remember anything we do to this to keep the structure, we will not lose our way through a question. And it comes down to that. Once we lose that structure, people are doing calculations in their head and they've got answers, they don't know where to put them. If you keep the structure, it'll be obvious. So that's a really big focus for us, especially in this first lesson today. And we'll get going. So the way I'm going to play it is I'm going to be zooming in. Look at this, crystal clear. Please go over to Patreon and get your copy of this workbook. Look, it's huge. It's 140 questions over a number of different pages. And get it so that we can actually go through it together. But the ideal is you're doing this before the session, and then you're confirming what you did and hopefully learning something new. We're going to be looking at this maybe from a brand new angle, something you've never seen before. Now, we said in the prerequisite skills, it's really important that we know how to, or at least we know our prime numbers. And this for this reason. Prime numbers are one of the best ways or best factors that we can have when it comes to breaking numbers down. And we'll see it here in this 36. You may really quickly recall that you would divide the top and bottom by the same number, and you think, oh, that's useful. I can do that little trick. I would strongly urge against that moving forward, because although that's how you deal with it in terms of numbers, it's a little bit harder when it comes to algebra. And I'll show you the scenario that always gets people. So x plus 1 over, let's say, x plus 7. Now, because it's on the top and the bottom, people often think we can divide by x on the top and the bottom and cancel it out. And that's due to the fact that they've seen it with numbers and they're not really dealing with the fact that these are two terms that are not like terms. Okay, they're different. Knowing that you have to be able to get factors on the top and the bottom in order to cancel down is the main reason, or at least a really good avenue to understanding why these cannot be cancelled. So I cannot take x out as a factor of the top and the bottom because it's being added to 1. Okay, and a lot of people cancel that and it's wrong. So we're going to look at it from that point of view, from numbers first, and then move into algebra. So we're going to rewrite this in a different way. And you'll find that most algebra questions, they kind of start like this. You'll have a question with algebra in it, and you're going to write it in a different format so that you can cancel it down. Here, you can go straight away and do it according to your standard methods, but not with algebra. So how do we do that? Well, our first method is to break it into factors, and the prime factors are the best, as we said. So 36, however you do your product of primes, it's essentially using only it's essentially only using the prime numbers to multiply together to get the result 36. Okay, so we start with 2, and if I had 2 times 2, that would be 4, and then I could multiply that 4 by 9 and I would get 36, so that would be 3 times 3. Okay, so I'm doing that in my head there. There are other methods that are a little bit more safe for you to use. Now the bottom one, 2 times 2 is 4, and then if I times that by 12, then I get to 48. So I'm thinking times 3 times 4, and 4 is 2 times 2. Okay, so just double check that all of that works. 16 times 3, yes. Now we have a fraction, and according to some of the work that we're going to do with fractions, it's actually really important to know that we can write this in a different way again. Okay, so first thing to know is that when multiplying, all of the multiplications are commutative. It means you can go in any order. So I'm going to match them up with the bottom. So 2 times 2 times 3 times 3 is absolutely fine. 2 times 2 times, in fact, they'll be absolutely fine to go ahead like that because they're already in pairs. So because they're commutative, we can do them in any order. But also, when we have a fraction that we multiply together and we put it together on this fraction that we have here, just as easily we can split it back to where it was before. So if you just take note of the pairs that we have here, the 2 on the top and the bottom, another 2 on the top and a 3 and a 3, the rest don't pair up. And we can write those as separate things, right? So 2 over 2 times 2 over 2, because they're all being multiplied together. And then it's easier to see what effect this has. And what's left, if we just highlight it, is a 3 on the top and 2 times 2 on the bottom. So we put that in one single fraction. And in fact, let's just go ahead and do 2 times 2, that's 4. Now, hopefully you'll notice that 2 over 2 is 1, because anything divided by itself is 1. And again, you've got 2 over 2, so that's 1. And 3 over 3 again is 1. And so when you have a factor on the top and the bottom, you can see, using the structure of fractions, like proof is inherent, that they just disappear. Although it's not magic, there's a reason for it. And if you just think it's magic, transitioning over from numbers to algebra is going to be super hard. Okay, so this is the real reason why, and hopefully now you can see, and you've got some tools that you can change one form to the other. I often say that maths is finding equivalence to gain insight. And this is what we did up there. We found something that was exactly the same, and then that gave us an insight into how that worked. Okay, let's get on with the next one. Try to make these videos snappy. Once we get into the above, we can hopefully start seeing that 45 is 15 times 3, and 60 is, again, 15 times 4. And back in the day, not too long ago, when you had your clocks, that was pretty easy to know the 15 times table-ish, because you had the clocks to remind you. If you didn't know that, you would have to use products of primes again, and that's fine. And now we can see that 15 over 15 is multiplying the fraction 3 over 4, where 15 over 15 is just 1. Okay, so 1 over 3 quarters is just 3 quarters. And I just might want to, up here, just write that that's 3 quarters, because it's always good to make sure your answer is nice and clear. Another way of looking at that is you could say, okay, well, I've got factors on the top and the bottom, and so I can sort of skip the step of this, and that's perfectly fine. Okay, now look into where we introduce algebra. It works exactly the same. Okay, so let's split the 14 into its products. And now we get to see a new part of algebra that we need to understand. When we have 14x, okay, what's in between the 14 and the x? Very important step to know is a multiply. So it's actually a product. Okay, so 14 is a factor and x is a factor of the product 14x. So we've got a multiplication already, which is awesome, but we need to split the 14 into its primes. So that's 2 times 7 times the x. And that works backwards as well. So if we have things multiplied together that are not like terms, for example, a number and an x, we can go back and write it like this shorthand for our answer. We're going to see that in a second. 28 is 2 times 2 times 7. That's 4 times 7. And that's just that on its own. And we can see very clearly we're pairing up these, and what remains on the top is an x, and what remains on the bottom is a 2. So if people are confused about, well, maybe they can cancel this fraction down, but like, where does the answer go? And that really is a big deal for some people. If I keep the structure here going well, then it's really obvious what goes on the top and the bottom later and what sort of form it's going to take. Okay, so we're moving up a little bit here with simplifying 21a squared b. And in this case, we have something a little bit more complicated. Put it down as a level 4, and we'll just stick to the same principle. And here's our next learning point. When we've got a squared, a with a little 2 up there is where we are trying to say that we're multiplying something by itself. So, for example, you might have 7 squared, which means 7 times 7. So whatever the base is, 7 there or a there, that base is being multiplied, is multiplying itself, essentially. And the 2 tells us how many times. So if it was a cubed, it would be a times a times a. That 3 is how many times. It's different, okay? It's different from when you have it in front. So 3x, what does that mean? So the number is not up there, it's at the front. When it's at the front, it means 3 times x. And another way of looking at multiplication is repeated addition. In other words, you've got 3 x's, so that's written as x plus x plus x. Same as 2x, or let's do a different letter, 2a is a plus a. So you've got to look at the difference for when it's in front of, when it's a coefficient, versus when it's an index of a number. The index means multiplying itself, and the coefficient, the number at the front, means adding itself. And let's continue to turn this into factors. So 21 would be 3 times 7. There's our prime factors again, product of primes. A squared is a times a, and then we've got a b on the end, okay? So just where you've got a right next to a b, that's the same as a times b. Okay, that's the little secret rule in algebra. When it's right next to it, it's times. I'm going to look to the bottom now. 35. Ooh, okay, so 5 is a prime number, and times that by 7 is 35. So we're there. We've got one A and we've got two B's. As I said before, you can do this without the prime numbers, but you can easily make the mistake that you miss the biggest factor that way. Okay, so what have we got? We've got 7s, we've got an A, and we've got a B. Okay, so we know we can write that like we did up here as the fractions out the front, where are we here, right at the top. And we know that they all equal 1 if they're on top and the bottom. So we can skip that understanding step in a way. And thankful for this structure, we can sort of talk about what's left. On the top is a 3 times an A, which you can go ahead and skip to 3A because you know when it's times, you don't need to write it. And 5 times B is 5B. And there you go, you've got your answer there. This is really powerful when we've got one method that allows us to deal with even complicated situations in a really structured way. What do we mean earlier when I was talking about the rules of this course? When you break something down like this is breaking it down. You're actually then just focusing on very simple individual things rather than looking at it as a whole, which is quite complicated. Okay, so breaking it down is just assembling structure, I suppose. Okay, we've got two last questions. Multiplying. So we're introducing ourselves to multiplying. We're going to just go ahead and do this, and well, we're going to see the effect of it. If we did 7 times 27, so 140 plus 49, so 189, you can sort of do that in your head if you're confident. You don't really want to do it in your head if you're not very confident, especially in the exam. Use a calculator, right? So we know that with multiplying fractions, and you may have seen that before, that would be the case. You would just multiply the numerators, and then you multiply the denominators. Well, that's 90 plus 36, so 126. Okay, so you might use a calculator, and you might do it that way. Where this might come from, if you want some intuition, is you might start to recognize patterns in sort of how things work. So, for example, a half of a half. What does that look like? Say we've got a block here, and we split it in half. Okay, so there is a half. That's my half. Okay, let's say it's a chocolate bar because I love chocolate, and that's one half. That top side. In fact, let's use this because it's going to look a bit neater. And then if you read the question, it's a half of that half. Okay, so how do we interpret that with maths? Well, if this at the top is a half and we want half of it, we're going to have to split that into 2 again. So what we have here is a half of a half. But what is that in total? Well, in order to figure out what this shape is, the whole shape must be split in the same way. So we'll just turn it into a shape that's got all of those particular rectangles. And you'll see that that is just 1 out of 4. Okay, that's an interesting one in the bag. We could do the same with a different one. Let's say we do a third times, let's go for something, maybe a sixth. So we'll think about how that works. Because of essentially means times, right? So we could interchange that with the times and it would be the same thing. But let's say we're having a third of a sixth. What does that equal? Well, actually, I know it's 1/18, right? But then how would we look at that graphically? So let's say we split something into sixths. So we've got 1, 2, 3, 4, 5. And they're not very, I'll try again. 1, 2, 3, 4, 5. You know what I'm trying to do? I know there'll be 5 lines, and I'm looking for 1, 2, 3, 4, 5, 6 equal sections. And they're not perfect, but it's good enough for now. And so we're looking at 1/3 of a sixth. So if this currently is 1/6, and we're looking for a third of that, that's when you split something into 3, right? So we can split that into 3, and we're looking for that little section there. What is that as a fraction of the whole? Well, it's actually quite good to extend those split lines in the horizontal so that we have only those shapes. And that's 1, and you can see here it's 3 by 6. So that's 1 out of 18. Now, just using those two examples, like practical examples with real-life pictures to go from, we can see where these numbers might come from. It seems to be that the two numbers, how do we get to the final answer, are multiplied together. So 1 times 1 would be the 1, and then 2, it could be 2 add 2, but let's go on the idea that it's times and see if it works for another fraction. So so far it looks good to multiply. Is that the case here? 1 times 1 is 1, yes. 3 times 6 is 18. Yeah, it wouldn't be 3 plus 6. It's like a function machine, right? Where you've got numbers that go in, And it's got to be consistent over a number of examples. Okay, so we've got 2 examples here, and it does work that if you multiply the 2 numerators and the 2 denominators, then you get the amount that you're after, because the of it actually in math stands for times. So that's a really cool way of seeing it. Now you could jump straight to that and then you could cancel it down. But what I'm going to look at now is how we can use our product of primes to make this a little bit easier for us. So if we write all of these as one fraction, you remember if we're multiplying them together, they can be combined to one fraction, because we've just established that multiplying means essentially that we're looking at 1 times 1 on the top and 2 times 2 on the bottom. So what does that happen? What's happened there? We've got 2 fractions that are combined into one fraction. And then that will give us 1 over 4. Same down here, it would be 1 times 1 and 3 times 6. Okay, so let's go back to our example over here. If these are being multiplied together, I could do 7 times 27. And that's really what I'm going to be doing. 9 times 14. Now, to avoid the trap of dividing the top and the bottom by something, right, we're going to go back to how we can use the primes. So 7 times 3 times 3 times 3. And that's essentially just to show you 27 is now 3 times 3 times 3. So I think you can verify is true. And then 9 is 3 times 3. And 14 is 2 times 7. All right, you can see straight away, can't you? You've got a pair there, you've got a pair there, and you've got a pair there. So you can see that you're left with 3 on the top and 2 on the bottom. So that's 3 over 2. That's without even doing really hard sums. We haven't really multiplied 7 by 27. That's really difficult. We've just broken it down. And so we saved ourselves a bit of calculation, or what we might call cognitive load, because that's obviously going to load our brain with information that we have to process, which actually is directly proportional to stress. Okay, so 3 over 2, awesome. Next is the same thing with algebra. See, now when algebra comes, it's always looking more nasty. And look, if we start adding extra letters, these questions can look like this. So we're going to build up to those. But in the meantime, we'll use the methods that we have so far, and we'll say the 4x is going to multiply the 15. So in essence, we've got the 4, which can be split into 2 times 2. And in between the 4 and the x, what is it? It's a multiply. So it's times x. And then it's times 15. And now remember that 15 can be written as 3 times 5. Okay, so 3 times 5. Let's move these even further over the way. Poor things. And we'll look at the bottom. So 9 times 8 is what's going to happen. This times this. And 9 is 3 times 3. And 8 is 2 times 2 times 2. You'll get used to that one. 2 cubed is used a lot. Let's look at pairs on the top and the bottom. We've got a 3 and a 3. A 2 and a 2 and another one. There's not an x, there's not 5 on both. So here is another skill. When you have multiple things left on the bottom, you have to combine them, but 3 is like 2. That's what we say in maths. They say they're like because you can add them together, you can work them together. They would combine nicely to simplify. So on top, we've got x times 5. You wouldn't write x5. That's another learning point. You'd always write the number first. A bit like when you're writing x, y, z, you wouldn't write x, z, y, even though it doesn't matter, but you just wouldn't because it's easier to see. And we all know the power of when we are used to what we're looking at, when we feel comfortable with it, it gives us confidence. And 60% of our maths exam is confidence. Okay, learning maths is a lot about how we learn to understand ourselves and give ourselves confidence and grow. And so learn to work with that. Now, lastly, 3 times 2 is 6. And now we're finished. And so we've simplified that. So we've multiplied it together and we've simplified it. And that's really all there is to it. You have multiplied these two together. But if you didn't do the cancelling out like we did here, you would have to go on and cancel out afterwards. And a little bonus for today's lesson, I'll just show you what that looks like. If I did 4x times 15, that would be 4 times 15, which is 60x. And that would be all over 9 times 8, which is 72. So you can multiply those together, and then your next step would be to cancel them down, just like you did in question 3. So prime factors, okay? So you would say, sorry about this, the pen, I'm going to write a bit slower. 60 is, and that's also multiplied by x on the top. And on the bottom, we've got factors of 72, which are, so that's 4, 12 times 2 is 24 times 3 is 72. And you can see that that's the same as this. It depends how you want to play it. You could do 60 over 72. Don't forget that on a calculator, if you're really stuck, you can put 60 divided by 72 and press equals, and it should give you 5 over 6 in the answer. So you can double check. But if you can't use a calculator, you can't do that. All right, I'll see you for the next set of questions in about a week, where we'll go over the next page of questions. It's looking like this, and hopefully we'll be on track. When you're learning maths, okay, you are going to be focused on one particular thing, okay? This is your eye. I know it doesn't look great, but let's say that's your eye, okay? And you're focused on one particular topic. And then when you stop learning, you sort of relax, that topic can interact with different topics that are already in your brain and make connections. And then when you see that topic again and you have to problem solve, you can use those connections as necessary, and it gives you more ideas and a stronger understanding for the problem solving. So relaxation in between work is really important. All right, see you in the next one.